Question 11. This is again November 25, paper 2, TZ1, right? Sorry, I've been saying TZ3 a lot. This is TZ1. Yep, these have all been TZ1. So go check out the playlist, TZ1. And so all the questions, previous questions are there, and question 12 and 11 will go up soon. So definitely drop a like and subscribe if this helps, and we'll just get started. Use integration by parts to find arc cos x, the integral of arc cos x. Let's get that done. Cos x dx. Now, when they say this, they're talking about separating it into two parts, and we have a 1 here. And what we're going to do is take dv is equal to 1, and so v, it's like dx, so v is equal to x, u is equal to arc cos x, and so du is equal to 1 over root 1 minus x squared negative, right? It's in your data booklet as well, so definitely check that out if you need to, but do remember this by heart for your exams. And so we just do is equal to vx, that is x arc cos x. Then we have minus the integral of v, which is x, for du, right? But we know what du is, so then we just plug in dux. Du is -1, so let's do this, and 1 over 1 minus x squared dx. Sorry, there's an x there as well, so we do that. And let's make this positive. And then, so what we have is cos x, and this is essentially, let's multiply, let's do something here. Let's multiply by -2, or actually let's do trig substitution. So trig is, let's use a different variable, alpha is equal to, sorry, sine alpha is equal to x squared. So then x is equal to root sine, sorry, let's, x is equal to sine x, then we have dx is, yep, equal to cos x. Sorry, let's use a different variable for these. Dx is equal to this, and that is d theta. So actually what I was going to do first is regular substitution, but we can do it both ways. So let's try regular substitution, and then let's try this. So what we have is, let alpha be 1 minus x squared. D alpha is equal to -2x, right? And that's why I brought in that -2. And so then we divide by -2. So we make this was plus, but we turn this into -half. Let's do that. And then so this becomes, right? And then this is simply d alpha 1 over root alpha d alpha. And so this is we divide by 2, so that means we have to multiply by 2. So that gives x arc cos x. Let's cancel these out. And we get root, what is alpha? 1 minus x squared, right? And that gives our answer, plus c, of course. Now the other way, using trig sub, would just be x 1 minus x squared, and I'll be using this. So let's do that. Is equal to x is sine theta. Then we have root 1 minus sine squared theta. And so this looks awfully familiar. We know our trig identities, right? And dx is substituted with this, so cos theta d theta. And so what we get is sine theta cos theta over cos theta d theta, which is just sine theta d theta, right? And that is just negative cos theta plus c. Now what we need to do is find cos theta given that, right? So sine, we need to use our triangles. Theta, sine theta, we said is x, so that means we have x over 1. And we need to find this. We need to find our adjacent side, so that is just root 1 minus x squared, right? 1 squared minus x squared. And that is what this side is. And so our cos theta is just negative 1 minus x squared over 1, right? Adjacent over hypo plus c. And that is exactly what we have here. So both methods work. So either method you can use. Now I'm going to reduce this so we have more space for the... Okay, something just happened. Okay. Now let me reduce the size. Okay, a bit slow. Now what we have is part B. Part B is the probability density function of a random variable x is given by this piecewise function. Show that k squared arc cos k squared minus this is equal to 0. Okay. Now, what we know about probability density functions is area under graph is equal to 1, right? Or total probability. And so what we can do here is just take the integral of 3x arc cos x squared from 0 to k dx, and we just did the integral for arc cos x, right? And we have an x squared inside it instead, so let's use u sub u is equal to x squared, du is equal to 2x dx, and we have 3x here, so we need to bring out that 3, and we need to divide by 2 so we can bring in the 2x arc cos x squared dx. And so we just replace that, right? We have this 2x dx. We just replace that with du. So that's 3 over 2 integral, again, 0 to k of arc cos x squared is u, and that's du, right? Now, I hope you guys can see where this comes from. 2x dx, we're just replacing that with du, and then our x squared we're replacing with u. And that simplifies everything for us. Now all we have to do is solve that using what we just found. So 0 to, sorry, we don't even have to do the integral. We just bring in our result, x arc cos x minus root 1 minus x squared, and there's a k, and there's a plus c, but we have bounds now, so the plus c does not make a difference. 3, 2, then we have k arc cos a minus root 1 minus k squared, and then we have 0, right? And then we have 1 minus 0, so that's minus minus plus 1. And that is that what we get? Yes. So all of that. And remember, area under the graph is equal to 1. So let's bring that here is equal to 1. So what we have is 3 over 2. Let's bring the 3 to the other side since we have a 1/3. And bring the 2. So we have k. Where's the k squared coming from? Ah, sorry. I've been using x, u, u. And so this is or x squared. Okay. So now we have to do x squared. We have to replace our u's with x squared. So x squared. This is a u again. This is x squared, so that becomes x to the 4. And that is it. Now, let's solve that. Let's do k squared arc cos k squared minus, yep, and okay, important thing to remember, which I forgot to do, is when we change our variable, when we change it to u, we need to change our bounds as well. So since u is equal to x squared, our bounds lower, u lower is equal to 0 still, u upper is equal to k squared. So that is what we can do instead of changing this to x. So then we can have k squared, and then what we have here is k squared whole squared, right? Hopefully that makes sense. And then k to the 4 plus 1 is equal to 2/3. Now I bring that to the other side. K squared minus root 1 minus k to the 4 plus 1 minus 2 to the 3. That's just 1/3 is equal to 0. And that is exactly what they asked us to show. That is our answer. Hence, find the value of k. Give your answer to direct to 6 significant figures. So let me reduce the size of this. Nope, did not work. We finally did, and then we have part 2. Find the value of k correct to 6 significant figures. So we just put this into our calculator and do an end solve. Let's put this in, do this along with me. We have x squared arc cos x squared, and then we have minus root 1 minus x to the 4 is equal plus 1 over 3. Okay, 1 over 3 is equal to 0. And so the answer I'm getting, we need to take our positive k is equal to, does it say? It says, so k has to be positive, right? It's greater than 0. K greater than 0, therefore k is equal to 0.713249, right? And we give that to 3SF. Oh, six significant figures. What is the one digit after? That's 9662. Okay. So 71324 is what we need to do. Right? That's 6SF. Perfect. Now let's do part C. Find the expected value of this probability density function. And so we have this formula in our data booklet as well, right? It is just the integral from on our domain, which is 0 to k, and our k, we know our k, and we also know that it's x times our probability density function dx, right? This is our situation, our key formula. So all we have to do is put this into our calculator. We know k is equal to, in fact, you just leave it as k, and x, so put it in 3x squared arc cos x squared. And here they're not asking us to show anything, so we just plug it into a calculator. It's probably 1 or 2 marks, and that would be calc k 3x squared arc cos x squared, and we have our bounds 0 to k is 0.713250. So we use that, and I get an answer of, let's say e to the x is equal to 0.456, and I can show you the trailing digits so that you guys can compare. But that's roughly 623SF, always 3SF. And now we have to find the variance, right? Let's make this smaller to give ourselves some space. Okay, hope you guys understood that. Then we have part 2, or variance. Variance is given by similar formulae, but we have multiple options, and we also have one in terms of e, in terms of our expected value. So let's just use that. We have ex squared. Sorry, let's write it out fully. Variance of x is equal to e x squared minus e x whole squared, and that is, now to find, so this is just the square of the value we just found, and to find this, which is the average of the squares, not the square of the average of the squares, what we need to do is, instead of multiplying it by x, we need to multiply it by x squared. So similar to this, let me make a new key formula. Not sure if it's in the data booklet. I do not believe so. Ex squared is our integral from the same domain of x squared fx dx. So this is an important thing to remember as well. And so all we have to do is use the exact same integral function that we used for this, just multiply by x, so 3x cubed instead, and we use the same integral function on our calculator, and I just changed the 2 to the 3, and I got 0.2371987,394. You guys can check against that. And then we just square what we got here, so 0.456 dot dot squared, and that should give me, let's do answer minus 0.4563094 squared. And what I get is 0.02898 04. Yep, hopefully that's close enough. And let's put that to 2SF, 3SF, 90, 3SF. So that's our variance. Hopefully that's clear. And that is the correct answer. So now we have D. Given that our average is equal to our expected value and our variance is that, find our probability of, okay, now what does that mean is what we have to understand. First, let's find our standard deviation, right? So let's go D. Our standard deviation is equal to the square root of our variance, which is 0.02. Let's use our stored value, and that is, we do that quickly, root answer, that is 0.1702365,145. So we have our standard deviation, and so the probability, now we just have to find what our average is minus this. So our average, let's just find that first, minus standard deviation is 0.46, that's our EX. So 464563094 minus, or in fact, don't need to show all of this. Just use your calculator and give it in. That's equal to EX minus, which is, let's find out, 0.4563094 minus our answer. That is 0.286072885, and we have mu plus standard deviation. That is exact same thing. And we have 0. Let's make it 0. plus answer, and I get 0.626559145. Just for you guys to compare, by the way. In the exam, don't write so many decimals. And so essentially what we're doing here now to find the probability of whatever they asked us, I'm not going to write all of that down, is equal to, we have to use the range the domain that they gave us, right? And it's of the same function fx. That's our probability density. And so we just plug that into our calculator. No need to show. I'm gonna use the same integral, okay, and just change the bounds. So 0.6265459145, 0.28607288855. And now let's change the function itself to x squared. Sorry, the function itself is, what is x? X is 3x. So we have 3x arc cos x squared. Okay, that should be enough. And what I get is, let's see, 0.620. I get 0.6200012 da 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 da. And that is 62023SF. That is our probability. Hopefully that made sense to you guys. This is a long-winded question again. 18 marks. I think we did pretty good on time considering I was explaining all the formulae and walking through everything. But otherwise, we can do this much faster, right? I showed you 2 different methods as well for the integral to show that question. And so otherwise, we did pretty well. Do drop a like and subscribe, and hopefully this helped. Have a great week.